Hello, grade 6. This is our third online lecture. In this lecture, I'm going to explain a new lesson, which is Chapter 6, Literal Expressions. Our objectives are to write formulas using letters to replace the known magnitudes, and we are going to use the distributivity of multiplication over addition in the literal expressions. Okay, first of all, and before we start, let us say or let us determine what's the meaning of a literal or algebraic expression. A literal expression is a collection of numbers and of letters that represent numbers linked by operations. It could be addition, subtraction, multiplication, and division. So again, this expression, it's a collection of numbers and letters, or letters with letters. Okay, and they are linked by operations. We are going also to calculate the numerical value of a literal expression, where in calculating the numerical value, we need to replace the letter by any value. You know that a letter could represent any value. So we are going to give specific values for these letters, and we are going to calculate then the addition or the sum, the product, or the difference. So we are going to see it depends on the statement itself, and we are also in a statement that have more than one operation. We are going to follow the order of operation to calculate. Let us first start. We are going to translate this verbal statement or this comprehension statement into literal expression or algebraic expression. When I say, for example, the double of a number, that means it's 2x. Double, that means I'm multiplying a number by 2. For example, what's double 5? It's 10. What's double 3? It's 6. So as if I'm multiplying by 2. And now, starting from now on, if I'm multiplying two numbers or two letters or a number with a letter, no need to put the times. You just put them beside each other. So you have to know that if they are beside each other, then they are multiplied by themselves. Okay? What's the triple of a number y? The triple, you know, it's times 3. So what's the triple of 3? It's 9. What's the triple of 2? Is 6. So as if I'm multiplying by 3. So the triple of y is written as follows: 3y. As I told you, you just put them beside each other without the symbol of times, because starting from now on, when I put them beside each other, then they are multiplied. Okay? The double of a number increased by 5. So this double a number increased by 5. I'm adding 5 into it. So 2x plus 5. The triple of a number a, so the number is a, the triple of a number, which means 3a, is diminished by a. Diminished means subtraction, so it's 3y minus 8. So when you change a variable expression to a word expression, you can say the same thing in several different ways. So when you say plus, you can write added to, increased by, more than, the sum of. All these words, they indicate that you have to add to plus. Okay? So we are trying to find all the synonyms that represent plus. Of course, you are going to find a lot of words, but those are the common used, the most used words. Added to, increased by, more than, the sum of. Okay? You can use, for example, the word plus itself. Okay? Now what for subtraction or for minus? Minus 2 subtracted from x means the same as 2 less than x, or x decreased by 2. So all of them means you have to subtract. You can also say the difference. You can say diminished. Okay, all these words, they express subtraction. Now, what for multiplication? When I say x multiplied by 2 means the same as the product of x and 2, x times 2, or twice x, double x, triple x. All these indicates that you are multiplying. Okay? Now for division, you could say x divided by 3, or 1/3 of x, or the ratio of c and 3. Okay, so all these words indicate that you have to divide. So let us try to make a lot of addition, subtraction, multiplication, and division to see how we do them. I'm going to start first by addition. The sum of A and 8. The word sum means you have to add. So it's A plus 8. 4 plus C. Plus means add. 4 plus C. 16 is added to M. Means I already have M, but now I'm adding 16 to M. So it's M plus 16. So you have to pay attention to the words where you flip them or where you keep them. When I say plus, so the first number plus the second one. When I say sum, also the same thing. But when I say added to, that means you have to switch their places. So it's m plus 16. 20 more than f, it's f plus 20. T increased by r, so it's t plus r. Okay? Now let us apply on subtraction. The difference of 23 and p, so it's 23 minus p. 550 minus h, so it's 550 minus h. W less than 25, so you already have 25, but now you are subtracting w, so it's 25 minus w. So when you have less than subtracted from, you have to switch their places. 7 decreased by j, so 7 minus j. M reduced by x, so it's m minus x. And 12 subtracted from I, so it's I minus 12. So because it's subtracted from, you have to switch their places, because when I say 12 subtracted from I, that means I already have I at the beginning, and now I'm subtracting 12 from it. So it's I minus 12. So pay attention. Only the two words that you may switch them is less than and subtracted from. Okay? Now let us apply for division. The quotient of r and 19, so r divided by 19. X divided by d, x divided by d. The ratio of c to d, so it's c divided by d, or c over d as a fraction. Both of them works out because the fraction itself, it's a division. The price p per gallon, g, so it's p divided by g, or p over g, because as I said, the division is the same as the fraction. Let us continue. Now we are going to apply on multiplication. The product of 4 and x, so it's 4 times x. Only in multiplication you don't put the operation, you just put the numbers beside each other. To have numbers beside each other means they are already multiplied by themselves. And why do we do this? Because actually there's a conflict between times and x. That's why we don't put the times, because suppose now you want to put 4 times x, it's 4xx, so it makes a conflict. That's why only in multiplication we put the numbers beside each other to indicate that they are multiplied without putting the operation times itself. Okay, 20 times b, it's 20b. Twice x, it's 2 times x. 3 over 4 of m, you know that the word of represents multiplication, so it's 3 over 4 times m. 7 multiplied by x, it's 7x. Okay, now we are going to do the opposite, or in this exercise, we are going to have mixed practice. What's the meaning of mixed practice? Is that in one statement you may have multiplication with addition, or addition with subtraction, or the four operations together. Okay, so you have to read this. First of all, the first step is to read the statement several times before you start solving. So 8 more than 1/4 of D. So you have to check what are the operations that you have. The word more represents that you have addition. 1/4 of D, there is a multiplication. So the two operations that we have are addition and multiplication. I'm adding two things. What I'm adding is 8 and 1/4 of D. So it's 8 more than, it's plus 1/4, it's 1/4 of D, it's times. So it's 8 plus 1/4 times D. Okay, so in this statement we have a mixed practice, or a mixed operation. Let us continue. Read the second one very well. 5 less than twice a number. 5 less than twice a number. So we have less than, that represents we have subtraction. Twice a number means we have multiplication. So it's 5 less than twice a number. So it's twice a number, 2a minus 5, because as I told you before, when you see the word less than or subtracted from, you have to switch their places. So twice a number is before 5. So I already have twice a number. I'm subtracting 5 from it. So it's 2a minus 5. And by the way, you can choose any number. You can choose it m, and any letter. The number, twice a number, it could be A, it could be B, X, and you can choose any letter you want. 7 increased by the product of two numbers. So I already have 7. I'm increasing 7, so I'm adding to 7 the product of two numbers, to any numbers. So I already have 7. I'm adding to it the product of two numbers. I chose A, B. You can choose, for example, M, N, X, Y. They are multiplied by each other, so you put them beside each other. Okay? 1/2 of some number, so it's 1/2 of any number. Of means times, so you put them like this. A number m plus 6 times n. So I already have a number m. I'm adding to it, because they said plus, 6 times n, as you see. And now the sum of m and n. So I'm adding m to n. 34 divided by x. So I already have 34. I'm dividing it by x. The quotient of two numbers subtracted from 20. Great. So I already have 20, and I'm trying to subtract the quotient of two numbers from 20. So it's 20 minus the quotient of two numbers. So it's m over n, and you can write it m divided by n. Both of them works out, because fraction means division and quotient mean division. Okay, so only in subtracted from and less than you switch their places. The product of 6 and 3 less than a number. So the product of 6 and 3 less than a number. So I already have 6. I'm multiplying 6 by 3 less than a number. 3 less than a number, it's a minus 3. 6 times 3 less than a number, it's 6 times a minus 3. And you can remove the times. Okay? You can keep it 6 into a minus 3. Okay? Twice the sum of a number and 8. Twice the sum of a number and 8. So I'm adding a number to 8, and it's twice, it's 2 times this addition. So that's it. It's twice times, or twice the sum of a number and 8. Now we already have algebraic expression, and we are going to write it in verbal sentence, or in comprehension way. We are going to define it. In the first one, we have g plus 10. Okay, you may have a lot of solutions, okay? So this could be, for example, a number plus 10. Also, I can say a number g plus 10. I can say 10 is added to a number. I can say g is increased by 10. So there are a lot of examples you can put them, because for the word plus or for the operation plus, you may have a lot of synonyms. Okay, so all of them would be acceptable. 2p plus 4q. It's twice a number is added to 4 times another number. You can say, for example, double p plus 4 times q. Okay, you can put a lot of examples. 4 into a plus b is 4 is multiplied with the sum of two numbers. Okay, 8 minus 6x. I'm going to say 8 minus 6 times a number. You can say that a is decreased by 6 times a number. You can put a lot of examples. S to the power 2 minus n to the power 2. It's the square of a number is decreased by the square of another number. Because here I have two letters, s and n, I wrote another number. For example, if it was s squared minus s squared, so it's the square of a number is decreased by the square of itself. So you know that we have the same number in this case, or the same letter in this case. I wish that this till now is very clear. So till now we learned that if I have the verbal sentence, how do I change it into a literal expression? And if I have a literal expression, how do I change it into a verbal sentence? Let us match the equality with its corresponding statement. So here I have kind of equality. In the first one, minus 4n equals 5. So this is negative 4 times a number is the same as 5. So negative 4 times a number is 5. 4 over 5, n is equal to 5. So it's 4/5 of a number is equivalent to 5. 4n is equal to 5. So we say that 4 times a number is identical to 5. 2 over 5n equals 7. It's 2/5 of a number is the same as 7. So to indicate that it's equal, we say that it's the same as, is identical to, is equivalent to. Okay? 3n equals to 5 is 3 times a number is equal to 5. And minus 4n equals minus 5 is negative 4n times a number is the opposite of 5, because you know that minus 5 is opposite to 5. And now we are going to evaluate algebraic expressions. Suppose we have a to the power 2 minus b cubed minus 4c, and I'm going to replace a by 7, b by 3, and c by 5. To evaluate an algebraic expression is to replace the variables with their values. Then find the value of the numerical expression using order of operations. Let us solve it. So we have a to the power 2 minus b cubed minus 4c. If a equals 7, b equals 3, and c equals 5. So every time I see a, I need to replace it by 7. If I see b, I need to replace it by 3. And if I see c, I should replace it by 5. So look at this. I replace the a by 7, the b by 3, and the c by 5, as you see. So we replace them by their exact values. Now, according to the order of operation, I need to start by the powers, because parentheses, exponents, multiply or divide, add or subtract. So I need to start by the exponents. So I need to find what's 7 squared and what's 3 cubed. 7 squared is 7 times 7, which is 49. 3 cubed is 3 times 3 times 3, which is 27. And now I'm going to apply that. First of all, I need to find the multiplication of 4 times 5. Okay, so we need to multiply 4 times 5, which is 20. And now we need to calculate everything inside the parentheses, which is 27 minus 20, it's 7. And now 49 minus 7, it's 42. So it's a very easy steps. First of all, you replace the letters by their exact values, and then you apply the order of operation as we learned before. Let us do some examples. So first I need, you should know now that every time you see the letter A, it's 4, the letter B is 2, and the letter C is 7. In the first one, I'm going to calculate 3AC. So 3AC, it means 3 times A times C, because as I told you, if I have numbers beside each other, they are multiplied. It's not 347, okay? They are multiplied by each other. So it's 3 times 4 times 7 and not 347. So 3 times 4 times 7 is 84. Now 5b cubed. B is 2. 2 to the power 3 is 8. So we have 5 times 8, which is 40. So step number 1, we replace the letters by their values, and then we apply the order of operation to solve. Now A, B, C. Then A times B times C. So 4 times 2 times 7, which is 56. Now 5 plus 6, C. Instead of C, we are going to put 7. So we have 6 times 7. So it's 5 times 42, which is 47. AB over 8 means I need to multiply A by B, then divide it by 8. So we will get 4 times 2, which is 8. A divided by 8 is 1. Okay? 2A means 2 times A minus 3 times B. 2 times A minus 3 times B. A is 4, B is 2. 2 times 4 is 8, minus 6 is 2. Now b to the power 4 over 4. B is 2. 2 to the power 4 is 16. 16 over 4 is 4. C minus A. C is 7. A is 4. 7 minus 4 is 3. 20 minus BC. BC means B times C. 20 minus 2 times 7. 20 minus 14 is 6. 2BC, it's 2 times B times C. Means 2 times 2 times 7, which is 28. AC minus 3B. A times C minus 3 times B. A times C is 28. B, 3 times B is 6. 6a squared, it's 6 times 4 squared, which is 16. So 6 times 16 is 96. 7c, it's 7 times 7, which is 49. 6a minus b, it's 6 times a minus b. C, 6 times a is 24, and 24 minus 2 is 22. AB minus C. A times B minus C. A times B is 4 times 2 minus 7. 8 minus 7 equals 1. So what did we learn till now? The most important thing we learned about is how to change a verbal statement into algebraic expression or literal expression. Algebraic expression means using letters and numbers linked by operations. And then we learned what if I have an algebraic expression, how do I express it in verbal sentences? After that, we learned how to evaluate an expression. To evaluate an algebraic expression, you need first to give values for the letters and then replace them and then apply the order of operation in order to continue. Okay? Now, the last thing I'm going to talk about is using parameters in algebraic expressions. Express in terms of A, the parameter of the adjacent polygon. You know that the parameter of any shape is the sum of all sides together. So I'm going to add the sides in order to find the parameter. As you see in this polygon, all the sides are equal. So the parameter is a plus a plus a plus a plus a. And all of these gives me 5a. So this is an algebraic expression that contains numbers and letters. So the parameter is 5a. Now if you give a any value, for example, suppose that a is 2, you are going to replace the a by 2 and then you will get 10. If you replace the a by 4, you are going to get 20 and so on. So that's why when we tell you, for example, the perimeter of a rectangle is side plus side plus side 1 plus side 2 plus side 3. Okay, so we try to use letters or symbols in order to find the perimeter, because we at first we don't have the exact value of the sides. Okay, now for example, in the square, look at this square. You know that the square, the perimeter of the square is the sum of all sides, right? um and all the sides in the square are equal, so it's side plus side plus side plus side equals 4 times one side. Okay, because they are all equal. So starting from now on, you should be able to know that the perimeter of the square is 4 times side. And if you replace the side by any value, you are going to find the parameter. As they gave us in the example, they told us that the side of the square is now 5 centimeters. How can you find the parameter? So you just tell them that usually the parameter is 4c, or 4 side, and I'm going to replace the side by 5. So 4 times 5 is 20 centimeter, and this is the parameter of the square. So what you should learn is that when you have a square, the perimeter is equal to 4 times side, and whenever they gave you the side, you just replace it by the letter and you calculate, and it's 20 centimeter. Okay, this is one example of the where do we use algebraic expression in real lives. Okay, so using them in perimeters, in areas. This is the first example. Okay, so now you are able to write the algebraic expression from the verbal sentences, or write the verbal sentences from the algebraic expression. You are going to evaluate the numerical expression of a certain algebraic expression. So you just replace the letters by their values and apply the order of operation to calculate them. And we are going, or at last, we used the algebraic expression in parameters.